Hey folks, welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Brent McCoy, I'm the CNCF ambassador, and I work as the head of platform at Basic, and I'll be your host today. Every week we bring you a new set of presenters to showcase how to work with the Cloud Native technologies. They build things, they break things, and they answer your questions. In today's session, I'm happy to introduce Dimitri Chuko. He's from BellSoft's, presenting us on some Java images, which I'm super excited to hear about. This is official live stream of the CNCF, and as such is subject to the CNCF Code of Conduct. Please don't add anything to the chat or questions that would be in violation of that code, and basically just be presentable to the presenters. So with that in hand, I'll hand over to Dimitri. Dimitri, welcome. Thanks for being here.
Thank you, Brett. Hi everyone. I'm Dmitry Chirkov from BellSoft. I work as an OpenJDK developer, and here I present some things that we built for cloud, for being cloud native in Java space. The company was targeted to provide best OpenJDK services and started with building OpenJDK binary distributions, provided support, fixes in OpenJDK. And after that, like 5 years ago, we realized that containers are the current trend, mainstream in the industry. So started to work on providing better experience for containers, more effective containers, container, things like muscle support in OpenJDK. And after that, we realized that, okay, probably it's time to join the expertise and create our own version of Linux that will be somehow suitable to daily tasks of Java developers or operations in the cloud. And that's what I will overview today. So we'll start with the very beginning. We will have some application. And having created this application, I've just slightly modified the configuration, but we'll start with the very default settings. So all the changes are commented here. So this is a well-known example, Spring Boot application. And Spring Boot is the most popular framework for Java and Kotlin applications. This is a classical pet clinic example that includes many things that the framework provides. And we have, so on this computer, we have the source code for this application, the project, right? And it's described in this case by the Maven project. And it's very simple. So we need to build it, right? And to package as a container. And we actually can have many options here. So do we have any kind of very basic and default options? Yes, we have. So some naive developers will start from the very beginning and will try to say, okay, we need JDK for that. We need a JDK, which is probably an open JDK, which is a project. So we need the binary distribution. So you need to get it somehow locally on your computer and to build this project, right? This is a Maven project, so Maven only requires a JDK, and then it performs the build described in this configuration file. Well, but in modern time, when we say we need to build this application using Java, right? We take it somewhere and just say, let's take a container and let's run this tool using a container and let's build it. Well, probably it's somewhere here. So yeah, let me find a command. So we'll start with building the image. So we're going to run a Maven inside this container. So we start a container that reuses the local Maven repository. So here it's mapped. We say, okay, this is our current folder with the project, and we start some JDK. We need JDK, and we select some flavor of it. I will show you some flavors a bit later. So here we are inside the container. Right, in this example, I will run commands separately, but of course we can form a single command line of it, or we can create a builder section in our Docker file, right, in the CI. And this builder section will create build artifacts from our source code. A tiny problem here is that we won't be able to reuse that Maven Artifactory local one that easily. So here, just I'm showing it for speed up. As I have all the artifacts locally in this repository, the build will be quick. So I'm going to this project folder, and I can perform the build. So as it's Java, it doesn't really matter how we build the jar. So I took some effective JDK container, a very slim one, but still it's a full-scale JDK. Let's give it some breath. So you see, we get it built, and I haven't installed Java locally. So in this project, I have a Maven wrapper, and I use the JDK from the container. So easy. And as we use that mapped volume, we can actually see our project build artifacts when we exit this container. Let's check the target folder and see, yeah, we have it here. Yeah, slight problem is that it was run from root on the root user, so I can just fix it quickly. Just avoid some potential problems. Okay. We have it built. Well, of course, the next step would be let's package it into a container, right? Or we can just run this application. Basically, it can be run just Java as java.jar and can have this jar file right here. Here's how we run it locally. And you see it's starting for some time. And after it's started, we can switch and basically access this application. Yeah, we have it. Not a big deal, right? So let's package this application into a container. How would many start approaching this task? Well, there's an easy way, of course, right? I guess all of the attendees have seen such Docker file in their career. And it's not too bad, right? Because we can easily check that it works. Here, let's just take the same thing and package the stopper file. And this resulting container is called pet clinic simple. Right? I have most of the layers cached, so we can see the images. You see there's our simple pet clinic. This is a simple application, and you see it takes like 500 megabytes. What is in there? So yes, there's a big base image because if we look at the original jar file, it's under 60 megabytes, and we have almost 10 times more a big container. And what's even worse, this container has some other problems. But let's start from the obvious ones. The base image is deprecated. So if you go to this page, to the page of OpenJDK image, you'll see that it has been deprecated, and it's so for quite some time. It recommends you trying some other alternative official images. So all the official images are listed here. And the Liberica runtime container is not an official image, but it's a verified publisher image. So it also can suit the same goal. And if you go to the BellSoft's page in Docker Hub, you'll see a lot of images. I already have mentioned Alpaquita, which is the base operating system here. And you see there's an image called Alpaquita Linux base. This is the core operating system image. And here on public Docker Hub, there are so-called stream releases of Alpaquita, on which all other public images are based. And there's a guide saying, okay, you can use these or that. And basically, the interesting detail about Alpaquita is that it's provided into branches to create flavor domains. It can be either muscle-based or glibc-based. Alpaquita is mostly similar to Alpine Linux, so it also uses APK package managers in BusyBox, but it's a different operating system, and it's really provided in that two flavors, so you can get glibc out of the box. If we look here, this image, and we can check tags. You can see stream muscle and stream glibc and all other versions named in the same manner. On top of that base image and packages provided by Alpaquita, there's a bunch of different public images, including Java. But that's not just Java. You can see Python mentioned here or GCC mentioned here. So you can use that small base images in your CI or production as an alternative to other big ones. And we'll see what it gives when you replace one by the other. But first, let's check some other problems, some potential problems here. Yeah, we already inspected that. Oh, yes. How will you run it? Because we have built the container, right? So we can actually run the built image. Let's check that it works at least. So we have its example, and we'll run the same Okay, this one is stopped. And here we're starting it in a container. It's the same Spring Boot starting process. Nothing really changed that much. Okay, it takes some time. We can check our application again. Yeah, you see that it works. So we've built a working container, not the worst one. Let's stop it. All right. We can run some security scanners against different images. And to compare some, we'll use that initial simple image, and we'll use some alternatives. Or we can simply look into their base operating systems. So for example, if we scan that OpenJDK image, we'll have long report of known vulnerabilities being there. And it's also true for many other famous-based images. Like quite some time ago, I've used some scanning by JFrog, and I gave that interesting results. A lot of high-end critical vulnerabilities in very popular images, which I would say sometimes is scary, but we can manage. I already mentioned Alpine Linux. So if we perform the same scanning today for this image, we'll see that, yeah, there are no vulnerabilities, fixed ones. But how does that apply to Alpaquita, for example, which is in many sometimes can be considered very similar to Alpine? We can check some CVs from here. We can take one from here, and this scanner tree in this example doesn't work with Alpaquita. It doesn't support it. So scanners have to support new operating systems, know how they work internally, or they sometimes try to figure out things about unknown systems by looking at their alike systems, but that's not the case here. But we can go to the security advisory. So for Alpaquita, there's a security advisory on the documentation portal. You can find it here. So that's the portal on bellsw.com website. I can actually enter the interesting CV from here, right? We have it, and we see what's the impact and where it was fixed, or maybe if it hasn't been fixed. In this case, you see it's all fixed. And it's already published in the base images of Alpaquita stream. So let's get back to creating a different Docker file for our application. As I've shown you, we can skip the builder part and let it be a separate step in our build process to speed up the overall build as we cache our Maven artifacts in local repository. So here, of course, can be a build part. And we start from a Berkeley runtime container, which is a base image with Java by BellSoft's. We will use a JRE because why not? We can say, let's use the slimmest Alpaquita image we can use here for this application and for the goals that we're trying to reach. So let's not include the components that we don't need. So we denote the exact version of Java that we are going to use. We say, okay, we need Jari, no JDK tools for this stage because we have already compiled it. And we are going to explode the previously built jar because it improves the startup process of Spring Boot applications. And it allows us to create separate layers and update our Spring Boot applications faster because we only need to update top layers. In the best case, only the very top layer with the code of our application, which is a tiny thing for a microservice. And you've seen that the resulting fedjar, so-called fedjar, is almost 60 megabytes. The business logic code there is just a tiny bit. So we extract that layers in our optimizer step. And then we prepare our runtime image where we say, okay, let's also run on Jari, and that will be a muscle-based container with Alpaquita and Liberica. Let's create a user. Let's expose port and do some settings for our container performance. Of course, you need to set some default JVM options. Don't leave it totally blank, because otherwise you'll get poor ergonomics. It won't break your container. So for a long time, Java survives, but it's very conservative on using your resources. So here we say, by default, please use 80% of your memory. And we create layers from exploded contents of our jar file and say, yeah, use the very precise launching point for this application. So we are ready to try that, right? And let's so it works now. We get this build process running. And if you have a clean repository, it will be very fast, surprisingly fast, because all that base images are very slim. So let's look at the resulting images. The simple one and the advanced one. I have multiple. But you see, the simple one is 531 megabytes. And it's not layered. And this advanced one is 195 megabytes. And it's a layered image. And it provides the same functionality. And it provides you a better level of security. Small surface attack, clear Linux for targeted for Java, supported JDK, etc. So we can run it. Let's do a basic testing. So I've picked some Java options here. We're starting. Hooray! The application works. But building and using your own Docker file may be not the best option. So there are multiple alternative approaches that can be used to build an effective container image with your Spring Boot application. One of them is to use Google Jib, right? It assembles an image using very advanced tooling. It even doesn't use Docker build for that. So you perform the task directly in your Maven, during your Maven build. So to achieve that, we can add Jib dependency, right? And we'll compare resulting images. Again, we'll look at the size, maybe some other characteristics. So I have a commented alternative option because we can configure a base image in the Jib Maven plugin configuration. But let's start with the default one. So here we are performing a Maven build, right? We can also perform it inside a container, but we'll have to connect our external Docker to this container, which is probably an overkill. So here we compile and say, please Jib plugin assemble an image for us, right? And we don't write Docker file by our hand. So it is also quite fast, as I have the base image used by default cached in my local registry. Yes, it's probably it has been updated. I don't know. All right. Yep. So we had it under 200 megabytes. It was 195 for the manual Docker file with Docker runtime container. With default Jib, it's still way better than naive OpenJDK manual Docker file, right? That was over 500, and here it's like 370 megabytes. And this one works. So 370, so let's replace it to BellSoft's base image. Just for fun, we have different base operating systems, not just Alpaquita. Some prefer Alpine, some prefer, Debian or even CentOS. So here, this is probably the tiniest Alpine muscle, of course, by default, but we also add glibc manually for some base images. You can find them here. Let's just quickly check it. So that's BellSoft's profile. And you can see, for example, library, OpenJDK, Alpine muscle, OpenCherry, CentOS. Or Debian. But that are three major base operating systems that we rely on, but we don't try to fix them by ourselves. We can fix Alpaquita, but not other operating systems. So we just test how Liberica JDK works there. Java is fine, everything is installed properly, and the layer that we control is minimalistic, optimal, and efficient, and of course secure. So we have it here in our configuration. And let's just repeat the build. So we only changed the configuration for this project. We haven't changed any code, right? We haven't changed any external tools because we have resulting image in one case, and we have same resulting image in another case, but it's slightly different because of the configuration in our main project. Here you see it's quickly being installed. As you remember, it was 317 megabytes, so let's just check it. And it became 202 megabytes instead. Well, still slightly larger than the image that we have crafted ourselves manually. So let's probably run it. So I have run command prepared somewhere. Right, that's again easy. Let's check that it works. So you see that it is convenient to prepare your build environment. Actually, not to prepare it as much as possible, right? To skip the manual preparation. So we rely on tools here and we get good results. And you see the application has started. And we see it's like finals. Work? Yeah, it works. Awesome. In the example that I started from, I took a container and performed a Java project, a Spring project built inside that container. And then separately, I took some other container as my base image and created a runtime image based on that compilation results. So doesn't that sound as a right idea for everyone? To use your builder tools, utilize them, consume them from some container, and then consume some base image for your runtime, and forget about all the complexities of tuning your CI. Sounds right, and it has been solved within CNCF boundaries. We have build packs. In particular, there are build packs for Spring Boot. So we can create a container from an application using just Maven without any extra plugins, using standard Spring Boot commands. That's what I somewhere here. Yeah, we have here. All right. So that's the example. We will create a standard so-called JVM-based container because there are now two different options here. From a Spring Boot application, you can create either a JDK-based container, where you will have hotspot inside some JRE, which is actually Liberica, because it's recommended by Spring, and it's used by default in Java build packs, both for build time and for runtime. Or you can create a native image from your application and get a container image containing the native image in runtime. And that's build image for your container to produce a native binary is based on Liberica Nick, which is a distribution, binary distribution of GraalVM. Well, let's see how it works in action. We just say Spring Boot build image for us, and Spring Boot itself builds an image. So it gets proper Docker images with all the build tools, arranges all the layers, and creates a resulting Docker file with some settings and some smart logic. Because in runtime, it not only uses Liberica JRE or JDK, but it also contains a starter script that is configurable, so you can tune it And it adds some JVM options looking at your environment. We'll see how it looks when it's built, right? Building the image, you see the Alpaquita has been used. And we're getting some SBOM information and many good things here. It's highly configurable. You can change the Java version, and flexible memory settings. And you see finally all the layers being added. So you see, we have it backlinking, or can just list. Yeah, let's see it. Okay. 3.3 snapshot. And the resultant image size is 387 megabytes, which is somewhere in between, right? Closer to the lower bound that we've seen. We can start it, right? And we can look at what happens in runtime. Okay. Let's see. This one. Of this version. So just take a quick look here. We haven't put much options ourselves, right? Students. But many options just appeared magically. The actual memory limits in this container have been detected. And based on the number of CPUs, we have the number of threads, so it has been detected as well. Or we had set as a default. And finally, we have useful JVM options, both for running your EM to make it use your resources efficiently and not to break. And then in the end, to provide you some useful statistics, again, about the resources usage, and most important about the memory. So it's all done for you without creating the Docker file manually, right? So we can check Docker stats. You see this container can take sometimes like 400 megabytes in memory. Yeah, like 400 megabytes. See, when it is stopped, it provides you useful information about your Java heap and your native memory used by this application, so you could plan your resources, plan your capacity, plan your ports sizing. Well, can we do it better? Yes, we can, because BellSoft has created an alternative build pack based on Alpaquita Linux. So you can easily configure it only by one single property in this same POM file. So let's see. Yeah, BellSoft 1 and BellSoft 2. So here we have used the default build pack by just changing the ID here, which actually refers an image. It's a Docker image. We can change the build pack, and it will use Alpaquita, and we'll see how it compares to the default one. So we'll perform the same build process, same command, right? We need nothing in our CI, just Docker and a JDK to run Maven wrapper, actually. It's already included in the project. We can do it for any project. It's the same build process. But we're using Alpaquita here. So this runtime part of the build pack runtime stack uses Alpaquita and Liberica Lite, which is specifically tailored for the cloud. And this is the flame of Liberica assembled to be more compact, more performant, so you can easily choose it, and it's included by default in all our container images. Yeah, by the way, if you simply need Liberica locally, you can get it for any platform you can imagine. Just go to our website, find the products, Liberica downloads, and you'll get to this page where you can select any version, any platform, packaging type, installers, whatever you like. Everything is supported and you get it for free. And we have the build process finished. Let's again run the container, or yeah, let's check the Docker images. You see the Docker image is smaller in this case. So, sorry, that's smaller. So it's 182 megabytes, a tiny one, not 370. So we've made it smaller. We've put well-controlled operating system controlled by the same vendor as the JDK vendor, and we can run it. You see all the same magic happens, same script works here, same parameters are detected, but there will be an interesting difference when the application starts. You see it has started, and it consumes less memory than the original one. Not a big deal, but for small services, that plays its role. So we save the memory by just using a slightly different build pack and base image in the resulting build stack. Okay, what else do we have here in Alpaquita images? Well, I probably won't cover very advanced topics of crack and native images, so I've prepared some. Maybe we'll look at CDS, or maybe we'll leave CDS for part 2. I see we need a part 2 here. I will just make a brief overview of different Liberica runtime images. As I mentioned, there's Liberica native image kit container, a container to build your native images. You can create native images for muscle, in particular for Alpaquita muscle, where you only need Liberica runtime base image to, Alpaquita base image to run your resulting binary, your Java application packed a single binary. Or we can look at very many different Liberica images. So Liberica runtime container. If you go here to Docker Hub, you'll see a long description explaining what different flavors or variants you can get here. Here's the main formula. So you can select what you wish. So you need either a JDK, so all the tooling, or you need only Jerry, which is actually a JDK too, but just without some tooling. So you will need a sidecar for diagnostics, for example, for JCommand, or you need to use your host JCMD, or of course, you want to have JavaC in your runtime image. You can select precise Java version, right? We provide basically all Java versions. You can even select Java 8, right? You can still run Java 8 in containers. It supports somehow your container limits. It won't break. You can choose an interesting thing called crack. If you need to bypass the startup phase, which we'll probably discuss in the next chapter of this story, you will need a special JDK, or you can try it locally, of course. And Spring Boot now supports startup or warm-up speedup, both by using crack or by using appcds. So to use appcds and speed up your Spring Boot startup effectively, you need a special kind of image with a CDS in its name. There are images specifically trimmed for cloud called Slim, which is my default choice, of course. The OS release can be a precise one that may be just stream or some numbered one. As I mentioned, we provide both glibc and muscle, and of course there are precise texts that point you to releases of the whole thing. So you can see here some examples, right? And the good practice is to use a precise version of your JDK for your container, or even for your builders in CI, because some behavior may be buggy from version to version, of course. And yeah, I think that we can proceed to questions. So I would leave the advanced part for the chapter 2.
Sure. So we had one question here from Joe Thompson. So the question was, do you have any kind of partnerships or other relationships with other companies working in the container image security, like ChainGuard?
Okay, not in particular with companies that work with security. We look at using different scanners, in particular, of course, what ChainGuard provides, what JFrog provides, but not in the partnership yet, I'd say. We are VMware partners here in the area of creating secure JDKs for Spring Boot containers, which is the major thing.
And that was all the questions.
Okay, great.
Dimitri, thank you very much. That was a great presentation. And
thanks, Brad.
Thanks everyone for joining Time Live Live, and we'll see everyone at the next one.